Greetings everyone. Today I thought I'd talk to you about restuffing electrolytic capacitors in old vintage radios. And I have on the bench today this 1951 Zenith 7G01 is the chassis number of it. I think the model number is an H724 or something like that, but it became real apparent when I first started troubleshooting this that this filter needs to be replaced. And so I wanted to do a video on it. I think I'm going to go ahead and restuff it, and there's some pros and cons to that. Most of the cons is that it does take a lot longer and is kind of tedious, and there's not many people who want to do it, but I wanted to do a video on it to show you how I do it, and you can formulate your own method of doing that. But most of the time when I'm restoring a vintage radio like this one, the filter capacitor itself is sometimes very hard to get to. And not only that, it can be very time consuming, removing all the wires and things. But what I wanted to show you is right here is where the bottom of the filter capacitor is, and I've got the wires removed from the lugs on it. This is a 4-section can, and what I wanted to show you starting out is you can actually get away with doing 3 sections on this, and I'll show you why. If you look at the schematic here, right down here is the sections 1, 2, 3, and 4, and this one section here, it's a 40 microfarad capacitor, and it goes and ties in directly to the cathode of the 35B5 audio output tube right up here. And so you don't really need to have this built inside the capacitor. I think they do that at the factory just to save time and expense. But if you look real close here, this yellow lead coming right here is the one that goes right over to the output tube, and it's pin 2, I believe, yes. And you could very easily just put in a small electrolytic 47 microfarad capacitor and just tie it from pin 2 to ground. It's real handy right there, and that'll save you having to try to stuff another one inside that, and it'll probably sound better anyway. So with that being done, the first thing you'll need is a really high wattage soldering iron to melt this solder on the chassis there. And so I'm going to go ahead and do that, and won't bore you with the details, but we'll get that filter out of there, and we'll get out in the shop and start cutting the can open, and I'll show you a good way to do it, and try to keep the vintageness of the radio itself. So, well, we got the capacitor out of the chassis, and it wasn't without damage to it, unfortunately. As you can see here, among other things, the 2 of the tabs broke off while I was trying to get it out of the top of the chassis here. Whoever put this in twisted these things to over 90 degrees, and trying to twist them back just ended up snapping them off. But I've got 2 of them still intact here, so that would be enough. But I went rummaging around in my junk box, and I came across this little jewel here, which is almost the exact same thing. Its length and diameter is the same, and I think the mounting plate on here is also the same thing. Although the capacitance is wildly different. This thing I think I got out of an old computer I used to work on when I worked for IBM. It's 3,000 microfarad at 15 volt, which is a little bit higher rating than this thing. 80, 40, 40, 40, 40. And but I want to keep the Zenith logo on this, so I think I might just salvage the ring out of this one. Now, if you go back and look at this capacitor, you can see what the problem was here originally. If you notice the bulge here, and it was leaking electrolyte all over the place here, and even back on the chassis here, you can see it just leaked all the way around here. And so it definitely has seen its end of life. So we'll go ahead and probably start out with this one, getting the ring out of here. Now, most people don't know, but the reason they put a steel ring in here is because you can't solder to aluminum, and this can is completely aluminum, and it's very difficult to solder to that, if at all possible, without special solder and a lot of heat. So they put a steel ring in here, and then they connect the electrodes of the capacitor to that steel, the ground to the steel ring, and then bring out the positive end here to a steel terminal. So we're going to remove this. There are a couple of ways you can do this. We can remove the, probably grind off the edge of this with a grinder, or we could get in there with a diagonal cutter, a good sharp diagonal cutter, and just start uncrimping this, going like that. I wouldn't use this small one, because if you put too much twisting on it, you'll just end up ruining it. So I'll probably just use a regular wire cutter for that. But at least we have a sacrificial one here we can try out. And also I found that if you're going to uncrimp these, you really need to put a piece of sheet metal around here, because the edge of that crimper, when you start crimping this, will dig into that, and it'll start denting it and boogering that thing up so bad it looks terrible. So we may just end up just grinding off the bottom, and when we go to put it back together, we may have to just put some epoxy around it, or some CA glue or something to hold it together. But let's get out in the garage and we'll get stuffing. Okay, we're out here in the nice cold garage right now. Got my heater running. Yesterday the wind was blowing almost 100 miles an hour, and I'm not kidding, for about 5 hours. But it's calmed down now, and it's cooled down a little bit. So we'll get started on see if we can peel this cap back. And to start off with, I fashioned a little protective sleeve here for the edge of the capacitor out of an old tin can. And I'm going to see how that works. Maybe that'll keep the marring down. And I'm going to use my good cutters just to get a start on this. See if we can peel that crimp back a little bit. Looks like we might have it there. So we'll switch over to a little more heavy duty thing and start laying back the crimp. And we'll see what that's done to the side. That's not too bad. We'll go ahead and work our way around. gloves if you're gonna mess around with sharp tin. Guess I need to get it over in the frame here a little bit. Okay. Grab our pliers here and see if we can pull that ring out. There we go. And that's a steel ring. You can see how they manufactured that, is they put the ground strap and probably spot welded it to the steel so you can solder it. And I don't think we damaged the edge too bad. Yeah, that's not bad at all. So I don't know, what do you think? You think should just grind that edge off or peel it back? I guess we could peel it back, and if it doesn't look too good, just grind it off a little shorter. So I think I'll go with that. This is the capacitor I'm working with, Zenith. Turn it around there. And we've just finished uncrimping around there, so I'm gonna see if this ring comes out as easy. Yeah, she's coming out. Yep, it's made almost identical to this one. I'll bet they're made by the same manufacturer. No doubt. And let's see if we can pull these out. Oh boy, those are in there. Those are really in there. Yeah, I think I'm gonna have to find another way to pry that off of there. So this thing's probably so swollen up it's going to be really difficult to get out. I'm feeling I'm going to end up pulling the lugs off of this thing. I'm not too careful. Well, I'm going to have to work on this a little bit, and I'll be right back. Okay, so I took a little Dremel tool and drilled a couple of holes here. Just enough to get a screwdriver under there. Maybe we can pry this thing out a little bit. Well, it's starting to come out. Whoops.
He's dead, Jeff.
Well, that's what you don't want to do. Snap the phenolic off. But there we go. Yeah, maybe I can CA glue that back together if I need it. Okay. That must be the seal. Keep the electrolyte in until I can't anymore. Well, all I can tell you at this point is be sure and save the lugs, because well, we've got 3 and that's all we need, but just in case we have to push them back through the ends of the phenolic there, we can. Boy, it almost looks like a piece of wood in there. That's quite amazing. Well, I must say I've never run into that before. Now let's do this. Let's see if we can make a really mess out of it. Hold your ears. Well, I don't think we're going to have any trouble getting the guts of this thing out. It almost looks like it's shrunk up. If you can see that, there's about a 1/4 inch of space between the capacitor wraps, and there we go. Well, that's it. We got that out. That thing really shrunk up. About that leaked and shrunk at the same time. Is that possible? Well, we'll go ahead and clean the rest of this out. Get it nice and tidy, and see if we can reconstruct the phenolic here. I might pull it out of this one just to use the guts on that if I can salvage that. But if not, I think a 1/4 inch piece of phenolic or plywood or anything would probably work for that. So I'll come back when I figure out what I'm going to do with this thing. Well, we're back in a nice warm lab environment now instead of that cold garage that we were just in. And I wanted to take a little time in this segment of the video to explore this old capacitor a little bit. This is the guts of it, what I call the jelly roll that we pulled out, and look how much space there is in that. Isn't that incredible? I don't know if this shrunk over the years. It could have. Things have a tendency to do that, and at 70 years old, I'm a little shriveled and stiff in all the wrong places too. So I think it was probably slightly bigger, as I could see in the tar that was on the bottom of this. There's a spot there to where I think it was just a little bit bigger. Anyway, I wanted to, like I say, explore this. This is a 4-section cap, and if you'll notice, they use these bonding straps to connect the plates. And if you're not familiar with how a capacitor is formed, it's like a jelly roll with 2 plates made out of aluminum foil, and we can cut this open here in a little bit and I'll show you that. Separated by an insulator soaked in an electrolyte, and I'm wearing gloves today because I have no idea what they used for electrolyte 7 years ago. I don't think PBCs were a thing back then, but if they were, it could be a little hazardous to your health. Anyway, you see this is the grounding bond, and these are the 4 sections of the capacitor, and I pulled it out of the radio that I'm restoring right now, and it does work, the radio, and it has just a very slight hum, but for the most part there's no problem with it. So I wanted to hook up a capacitor tester and show you a few basic tests that we can do to determine the strength and value of this capacitor. So let's just start out with this leg right here and see what it reads. And okay, that one reads 124 microfarads, and I believe it was supposed to be, one of them was supposed to be 80. So when you see one that's kind of an overachiever, you want to be suspect of it, because capacitors, when they start doing that, it usually means they're kind of leaky, because if you're looking for just a capacitor test, a lot of times it's a time thing, and it just measures how long it takes to charge that up over time. And if it takes too long because of leakage, it will show a higher capacity than what it's rated at. Let's take a look at some of these other ones. Okay, here's the other section. Okay, it's in the nanofarad range, which really this is open. That section is open, so we'll have to take a look at that later. Okay, let's try this one, and it's showing 65 microfarads. And the rest of these are rated at 40, so that should be 40. And this one is also, well, that's 95. I'm reading this upside down, so wow, 96.38 microfarads. Okay. That's one test you can do, and it may not always be accurate. Another test you can do is using a device like this. That I got this off of eBay for like $12, and it's really been proved to be quite a helpful piece of test equipment. So I'm going to measure this one right here, and I hope you can see that. Yeah. Get it over here so you can get a little bit, and we'll hit the test button here, and we'll give it a minute and see what it shows. Normally this will test the capacity. Okay, 115.6 with an ESR at 2.7, and looks like no voltage loss in it. And I have a sheet here of what this should be. If that is indeed the 80 microfarad section, we can look at this graph here. And at 160 volts, okay, this is rated 150 volts, but that's close enough. 160 volts, let's say 100 between 47 and 100 microfarads should be 0.77 to 1.6 ohms of ESR, and equivalent series resistance is what this will look like in a circuit, as if it had a resistor in series with it, and you don't want a whole lot of that. So I think our maximum here was 1.7, and this has kind of exceeded that. It looks like 2.8 on that one. Let's try one of these other ones here. I'll get my lead to stay on. Had to make these short because it will read lead resistance as equivalent series resistance too. And in this case, it's almost a full ohm. Okay, then showing 61 microfarads at 4.8 ESR. Okay, if that is indeed a 40, that's the way it should be. 40 microfarads, say 160 volts, should be a maximum of 1.6 ohms ESR. So that one's well beyond that. So it has a lot of equivalent series resistance. Let's try this one. I think this one was open. Okay, it's showing, oh, that's 60 at 4 ohms equivalent series resistance. That's way too much. This thing obviously is leaky. And this one's capacitance of 82 microfarads. Oh, look at that ESR, it's 8.9. Okay, these are well beyond what they should be. And so they are quite leaky. Anyway, the other thing I wanted to talk to you about on these is when you're working on a old radio or television or something that uses these CAN type or any filter capacitor for that matter, you want to discharge them before you work on them because they do hold a charge for quite some time, and you don't want to turn that into a defibrillator on you. So the way I discharge them is I have a 100 ohm resistor, and I just go from ground to these lugs here and just hold it there for a moment. You can measure the voltage if you want to. That would help also. But one thing you don't do, and I've seen technicians, especially older ones, do this in the past, they'll just take a screwdriver and just short between these two, and you don't want to do that. When you do that, a capacitor has a lot of energy in it, and the energy gets suddenly released, and you can literally blow the bonding strap right out of a capacitor. And then of course the capacitor is ruined for life. I mean, it's a goner when you do that. So don't short those out. You'll just ruin them. Use a 100 ohm resistor or something to bleed that off a little better. A lot of open capacitors are just that because the bonding connections got destroyed by a short. It could be a short in the capacitor because this is not much more than a fuse, really. There's a lot of joules of energy going through that when you suddenly discharge it, and capacitor's not built for it. Now, some of them are. I have here, this is a photo flash capacitor, and it is built for sudden discharges like that. And I've never taken one apart, but I suspect that the bonding connection is just very heavy, and it can take these sudden discharges of firing a flash off all at one time. And so there are some capacitors that can handle that, but for the most part in commercial electronics, they are not. And they are easily destroyed by that. The one good thing about having that done is if your filter does short out inside, if this little jelly roll just develops a short, sometimes they'll go open because they have blown this connection off, and that will save either your rectifier from blowing the bonding connection off the inside of your rectifier, or your transformer. And in some cases that transformer is made out of unobtainium, and you're not going to find another one very easily. And so it's one good thing about capacitor going open, but unfortunately probably 50% of the time they go shorted. So anyway, I wanted to show that to you, and let's just slice this thing open and see what we can see here. Looks like they used a little bit of tape originally to, oh, they did, okay. And what we have here is, I'll get my gloves to tighten up enough to, you can see where they've made the connection to one of the plates of the capacitor right here, and they basically just stamped it in there. And they may have spot welded it too, but that's the connection. And so you have one layer of conductor sandwiched between an insulating electrolyte material. Let's continue to peel this off so we can try to peel it off like a toilet paper roll here. Now we'll just continue. Some people think the world runs on computer chips, and I'm under the impression that it doesn't. It runs on capacitors. And they are a high failure point. Okay, and here's the lug to one of the, I would say it's probably, since it's the first lug, it's probably the, what was that, 80 microfarad section right here. And then we continue on. Oops, there's another section. That's probably, I might be wrong. That other one could have been the 40. This might be another 40. You can see it right in there. And you see it's that's the end of the plate of the capacitor. And here we'll probably run into another one right quick. There's one. And there's the end of the plate of another one. You can see that's not very big. It's only about that long. where this one was quite a lot longer, and this one even longer still. Look at that. That was a very large section. That's a shorter section and a shorter one yet, and now we're down to the last part. And that one was rolled pretty tight. I wish I would have marked these before I took them apart so I could tell which section was which. But I got a feeling it's pretty much what I told you. That one was really, really short. Anyway, that's what a capacitor looks like inside. So now you know, and now you know what to look for and when you're testing capacitors, because over the years that electrolyte dries out and these plates will begin conducting through the insulation there, through the electrolyte, and start what they call electrically leaking. Not physically, but electrically leaking. They will also physically leak too. You can see right here, you can see where the electrolyte is begin to leak out the bottom of the cap. So anyway, next step will be to stuff this with some known good ones, and I've glued this back together. If you remember in the other segment, I broke it off, prying it out of there, but I was able to use some CA glue and put it back in. And so we'll do that, and we'll also, I think I'll need some space to take up the room here on this, about a 1/4 inch of space almost. Now that I've got these properly glued together, I'm going to start with the largest capacitor and mount it first, and then strap the other two smaller ones next to it. But I need to punch a couple of holes in here. I found that since I covered this up with this phenolic and glued it together, I'm going to have to solder the leads on the other side of the bottom of the phenolic there to the lugs. So we'll get out the trusty Dremel tool and turn up your headphones. Here it comes. And hopefully the holes will be big enough now. Well, there we go. Okay, now I can bring this ground lug over to where the grounding ring will be, and just solder it to that ring, and then crimp over it when we get ready. So, and I think what I'll do is strap the ground leads together right underneath here, and then tape these capacitors together with some friction tape or something. So I think now we'll have to decide where I want to punch the holes for the other one. So I'll go ahead and do that, mark it, and come right back. Now that I got these roughly positioned where I want them to be, I'm going to solder the ground leads together. And I put a little heat sink on there to keep the majority of the heat off the capacitor, the big one anyway. Bring this over here a little closer. And I think that'll work just fine. Let's go ahead and position him on the phenolic now. Okay, here's the positive. All the negatives are tied together. Those two go in there. Twist this a little bit. And I think we'll do it that way. And while I'm at it, I was going to tell you about the capacitors. I'm using the large 80 microfarad one here, which actually is 100 now. The original was an 80 for the radio, but this is all I had. And it's okay to go a little higher on rating when you're working with filter capacitors. So this is an 80, and it's a United Chemicon capacitor, which is a US made capacitor, and they're pretty good quality. I've never had any problem with them. And also this capacitor here is a Matsushita capacitor, and you can tell by the, I don't know if you can see that or Amber, but the M inside the square there is their logo, and they don't really put their name on it, other than you'll see some writing in red here, and that's usually indicative of a Matsushita capacitor, and they're very good quality also. You don't want to put any cheap Chinese capacitors inside these things, because if they fail, it's going to be a real pain to get to it to repair it. So you want to use a good quality capacitor. So let's wrap some tape around this and secure it a little bit. I use some old-fashioned friction tape. You can use whatever you want, really. That there, and this whole thing should fit inside here like so. And then we can finish up packing this thing off and finishing it up. And I want to put in a little, maybe some foam padding in here, just to keep any vibrations down. If you're playing the radio at high volume level, the chassis sometimes gets to vibrating, and you don't really want a rattling sound inside that. So I'm going to wrap a little foam inside there and pack it off. And we'll also get to soldering the legs here, which I think I'll do right now, since I've got the camera on and we're running. We can do that one. straighten him out and connect him to the ground ring when we get a chance to do that. Here's one of the 40s. These are both the same rating. They originally were 40s. I put in 47s because you can't really find 40s very easy anymore. So we'll wrap him around this lug. Let's solder that guy on there. I'll try to keep the smoke out of your face there while we solder that. Okay, and this one came out right on the bottom of the lug, which is really nice. There we go. And I'm going to pause the video and go find some padding for that. And we'll be right back and we will continue on. Alright, I've cut a piece of foam out now and we're going to wrap it around this section of the capacitor, and we'll just insert him all inside here. That way things won't get loose and rattly, and we'll just push them down nice and tidy in there, and we'll get the ring put on and soldered on and start recrimping the can. Now before you go any further with this project, you want to make sure and take a picture or draw a pictorial diagram of how the capacitor was laid out in the radio chassis. Because it will matter a little bit if your lead length is kind of short. You want these to line up in much the same way as they were before you took them out. And in my case, the capacitor was placed in the radio with the ground lug right here that was soldered directly to chassis ground. And the 40 microfarad lead came out here, and the 80 leads came out here, and the other two 40s were there. But with that said, also, before you go any further, you really want to make sure you got this thing wired up right before you seal it up. And in this case, we'll take a reading here. We'll go from ground and to what I hope is the 100 microfarad section, and looks like we got 97.3. The next one, these two should read the same. They're 47 microfarads and they're reading 47.9, somewhere in the neighborhood. And this one should be the same way, 48.0, so very close. And now that we've got that wired in properly and haven't made any errors, we'll go ahead and apply the ring here and start crimping. Now I think we're ready to begin crimping this thing. And I've got out my trusty little miniature channel locks that I think will have enough angle on the jaws here to where we can start pulling in some of the outside rim here. Now that we're all the way around, I'm going to bring out something heavy here, and we're going to use a little bit of hammer power to this small brass hammer to tap these back down into place a little better. I'm going to go ahead and finish hammering this off all the way around off camera here, so as not to bore you guys to death. And we'll come right back and continue on. And at the end of the video, which should be pretty soon, I hope, I'm going to show you how to get started on restuffing these old wax capacitors. And I have a really easy way of getting the guts out of it. And I'll show that to you at the end of the video here. So stay tuned. Okay, I've moved the camera off the bench a little bit here so as to not make you guys queasy with all the vibration and stuff. And what I'm doing is I'm finishing up the crimp here just by using a punch and a brass hammer. And just re-crimping some of the high spots here. Let's see. Let's see if we can pretty this up. This is actually coming out pretty well. Better than I thought it would. This aluminum's fairly malleable, so it bends quite easy. I hope you can see that. I probably had my hand in the way all the time. I think we can probably, once we get the little, I think what I'll do is polish this up on the wheel of death out in the garage. I have a big polishing wheel out there, and I can shine these up really nice. But I want to tape off the Zenith logo and the values here with a piece of masking tape or painter's tape, and take it to the polishing wheel and shine this thing up really pretty, and put it back in the radio. And I don't think I need to show you that on camera, but another thing I thought about doing is, and I wish I had thought of this earlier when I was uncrimping this, was to use an old radiator hose clamp and put it around here like so, and just tighten it up to keep the edges from flaring out so bad. But it didn't turn out too bad. I'll do this the next time we try something crazy like this. might even this out a little bit. I sure hope I don't have to get back into this somehow. Hey, that looked pretty good. I don't know if you can see that well enough or not, but almost looks factory. Okay, yeah, I think we're ready to polish it and put it back in the radio. And the next segment, we'll go out in the garage and I'll get out the heat gun and show you a really quick and easy way to get the guts out of a little one of these little paper wax capacitors, if you feel inclined to restuff one. So okay, well, we're out here in the garage still, and I think I was just going to go ahead and polish this thing up a little bit on the wheel of death here. And we're using some yellow aluminum polish. I don't know if that's for aluminum or not, for chrome anyway. But we'll see how that does on this thing. Well, I think that polished up real nice, if you can see it there. And what I did is I masked off the logo and stuff, so I wouldn't lose it by polishing it out. So I think it turned out quite well. Oh, one other thing I wanted to mention, if you're going to use a polisher like this, you probably want to short the leads to ground here, because this thing will build up one whale of a static charge, and when you charge a capacitor with that kind of voltage, you could either damage a capacitor, or when you get your fingers across it, you'll get one heck of a shock. So just run a little shorting clip around there and you'll be all right. But yeah, I like that. So we'll see what it looks like in the radio. Hey, we're back in the lab now, and I wanted to show you the finished product a little closer. And this is it. We've got it all polished up, and I think it came out pretty well. And yeah, here's the bottom. Now the bottom looks quite ugly, to be frank with you, but nobody's going to see it anyway. But they will see the rest of it. And I was able to save the Zenith logo and the values of the segments in the capacitor, or the sections in the capacitor, as well as the part number and the date code. You can see there. And so we're able to salvage it. It goes down here in the old Zenith, and I haven't cleaned up the chassis on this yet, but I just wanted to see how it all fit in here. There we go. And I think once we get the chassis cleaned and polished up, as well as the IF transformers, and the radio does work. I've already tested that, so I think we're in business. So while you're looking at this thing, I want to thank everyone for subscribing. I have a bunch of new subscribers, and I sure do appreciate your attention there and your comments. And appreciate you watching the video. And now, as promised, I want to show you how we're going to take this cap apart and restuff it right quick. So stay tuned. Here comes the bonus video. Well, as promised, I wanted to show you guys how to extract the little jelly roll outside of the, or from the inside of this wax paper capacitor. And the only thing you really need is pair of heavy gloves or some heavy rags,
I use welder's glove because they're protect you from the heat a lot better. And what we'll do is we'll take the capacitor and we will, on the foil end, I like to use that, and clamp it in the vise, like so. And all you'll need is your trusty heat gun, and we'll heat this up until it just starts to almost discolor. And I put some towels on the floor because this will drip wax all over the place, so you don't want to do that. But we'll just evenly heat this thing up. Until it just begins to bubble. And it's cold out here today, so I've got my heaters running in the background, as you can see there. It's supposed to get down to 8 below tonight.
Here in north central Kansas. What I like to do is heat it up till it just
Almost discolors the paper, but not quite.
I've got this setting on high heat, so
I think we're about ready to give it a yank here and see if it'll come apart.
let's see what happens.
Stench.
Let us hear it for our poor dead friend.
Well, we lost part of it, so in that case we'll just flip it around and try it this way too. I'm going to heat it up some more. And
Sometimes that happens. Sometimes you just yank the end off of it.
in which case I have another option if it happens again. Let's see what that does. Well, things always go funny when you're doing live video.
Well, I found my screw starter, and this is
Very handy when you're trying to do this and things don't quite go the way they're supposed to. Anyway, we'll clamp him in the vise and move the camera a little bit. And what I will do is I will screw this thing onto the end of that. Like so.
and we'll heat it up again. Really is easier than it looks. It just didn't work out the first time.
Let's see if that happens now. Okay, there we go. There, that's the jelly roll, and now we're back in the lab again, and this is how this pulled apart and came out. And you notice the other end didn't come out, which actually is kind of a blessing, because really all we need to do now is get your new capacitor, stick her in there, and look at that. And then when you're ready, get your hot glue gun and just fill up the space with some hot glue,
and nobody will ever know the difference. They'll think it's a vintage capacitor. The only problem is they may try to replace it someday. Anyway, that's a quick and easy way to do it. If you need some space in there to fill in, you can always just wrap some painter's tape or electrical tape around that and put it in. But that's a quick and easy way to do those if you're so inclined to keep the vintageness of your radio or amplifier. Once again, thanks again for watching, and thanks to my new subscribers. I sure appreciate it. We'll see you next time.